So what is an insulator? An insulator is the opposite of a conductor, by which I mean an insulator doesn't conduct charge. All right, so why? Well, we've got our atoms, our nuclei down here, and then the electrons are in these blue bands. So notice that in this case, the electrons are each associated with a single nucleus. There's no mixing, there's no conduction band. Charge will not move to any appreciable extent. Small conductivity. So the conductivity associated with an insulator will be, rather than like 10 to the 8, it'll be like 1, or like 10 to the minus 5, or like 10 to the minus 16 sometimes. Like we're talking no charge flow. All right, so gases, ceramics, rubber, and all kinds of things like that play the role of insulators. Insulators are very, very, very useful because if I don't want charge to get into me, then what do? Well, I'll put on a rubber glove and then I can handle anything I want to, and that charge isn't going to come to me. So you've seen people with Van de Graaff generators standing there holding the very positive knob on top of that generator, and they'll stand on wood because wood is an insulator. It won't allow that charge to leave them and go into the floor. All right, so what goes on when I put an electric field on an insulator? Well, unlike conductors, the electric field inside of an insulator does not have to be zero. However, what will happen is the insulator will polarize so that the electrons will go upstream in the electric field and the nuclei will go downstream in the electric field. So they just kind of stretch out. They're not jumping. There's no, transfer of charge. They just kind of stretch out. So this is called a polarized insulator, or another word that people use for insulators is dielectrics. All right, so we could say that this is a polarized dielectric. All right, now, we've said that insulators or dielectrics do not conduct charge. Well, that's true unless we force them to. If we put a large enough electric field on an insulator, it will conduct charge. This is called the dielectric strength of the dielectric or of the insulator, or sometimes people call the breakdown voltage, the amount of voltage that you need to apply across an insulator so that it will conduct electricity. In dry air, this dielectric strength is about 3 million volts per meter. So once you get to an electric field that big, that's when you get lightning. The air, which was an insulator, now suddenly becomes a conductor. And that's insulators.